Hi students again. So now talking about we are here in rotational mass damper system and I go for it. Here is the simscape. Okay, so let's see the task. Good. You will follow the same steps to model in other domains. Add physical components, create the network, including both a solver configuration and the appropriate reference block, and specify values and parameters. In the next few tasks you are going to do, you will follow these steps to model a rotating wheel slowing down due to friction. Okay, you will use rotational elements from the mechanical domain. So you go to the mechanical domain. So let's see what's the task one. You need to go to the library, now you know, and find rotational elements. So now what I will do, I'll double click and find it directly this way. So I don't want to go rotational damper. Okay, rotational element, like the electrical reference, this represents a 0 point. In this case, zero angular velocity. Well, rotational element, yeah, so add a mechanical rotational reference, sorry, mechanical rotational reference. So, mechanical rotational reference from the rotational element. Like the electrical reference now, this represents a 0 point. In this case, zero angular velocity. This represents a zero angular velocity. Okay, that's simply the task one. And it's correct. Task two, to model the wheel and friction from the zero electrical velocity, you will need an inertia and a rotational damper respectively. So you can model the wheel and the friction. You need an inertia, you need a mass, and rotational damper. Add inertia block and rotational damper block, both from the mechanical. Okay, inertia. Inertia. Mechanical rotational element, so I can find the inertia. Okay, and rotational damper. Again, double click. Rotational damper. Sorry, damper. Again, this is a rotational damper, and this is the inertia. So then we can represent the wheel. We can model the wheel and friction. Set the damping coefficient 0.01 Newton meter radian per second. Double click on it. Newton meter radian per second unit 0.01. Okay, so I take out 1 0, and here it is, the first task. Okay, it seems correct. I go to the task after. So here my system, which is rotational damper, rotational reference, and inertia, rotating inertia. The engineering schematic for the wheel and friction system is shown below. When you connect the mechanical rotational blocks, the inertia mechanical rotational blocks, you will notice that they have R and C ports, right? R and C port. Like the plus and minus port in the electrical domains. This port determines the sign of the block value. Also, like omega is omega R minus omega C. Okay. R will go to the reference. Make the connection to model the rotational mass damper system. To model, yeah, make the connections to model the rotational mass damper system. Match the block orientation to the diagram. Don't forget to connect the solver. So now, how to do? This is the omega R minus omega C. That's how myself how I do the connection. Okay, and the solver I connect it anywhere. Good. Now this is the solution anyway, so let's check if everything is zero and so on. So far so good. Okay, let's go to the next step, which is task 4. A damped inertia in the mechanical domain acts like RC circuit. A damped inertia system in the mechanical equivalent to RC circuit in the electrical domain. The inertia stores energy like a capacitor, and the damper dissipates energy like a resistor. Thus, an inertia spinning with some initial angular velocity will slow down with an exponential decay like an RC circuit with an initial voltage. So then go to the values, expect, and and well, the inertia maybe it was given anyway. So the variable, which is the rotational velocity at the beginning, is 10 radian per second. So it has an inertia of 10 radian per second. Therefore, if I'm computing the angular velocity of the disk here, it should be starting from 10 and with time goes to 0. Let's submit it and check my response. All right, very good. So next task is a further practice. You do it yourself. As you have just seen, the steps to modeling a physical system are similar for all domains. All you need to know is how each component should be connected to the others. Try adding a rotational spring to create a rotational mass spring damper with decaying oscillation. Okay, maybe you can add rotational element and add rotational spring. Rotational spring. See, you can add it and try to work on it, okay, with it. Let's see next section now. All right.